Now we will discuss the excitation energy of hydrogen-like ions oblique atoms. The hydrogen-like atoms or ions are those which have only one electron in their outermost orbit. So the elements placed in the first group of the periodic table, they are the hydrogen-like elements like lithium, sodium, potassium, etc. And ions, if suppose there are 2 electron or 3 electron in the outermost orbit, and if if only one electron is left in the outermost orbit and remaining electron in the outermost orbit are removed, then this will be called the hydrogen-like ion. So hydrogen-like ion ion. Now these are your calcium, the elements the atoms having 2 electrons two valence electrons are divalent if one electron from 2 valence electrons is removed, then atom will have electron in outermost orbit will be 1. Will be 1. And it is like the hydrogen-like ion. So suppose we are having this your calcium now, this is now your 20 40. So here this Z equal to 20. So now the electron distribution is 2 8 8 and 2. Now these are 2 electrons. If this out of these 2 electrons, so 1 electron is removed, then this is now 2 8 8 1, removing 1 electron. Removing 1 valence electron. One valence electron. Then this will be now only one electron, and in that case this will be just like the sodium atom. So now this will give the spectrum just like the sodium atom and just like the hydrogen atom. So this is a hydrogen-like ion. So this is now only one electron, having the one electron only. So this is now we can similarly, if we have this aluminum 1327, so this Z equal to 13, then this now this is not 2, 8, 8 and 13 or 20, 2, 8 and 3. The 3. Now if 2 electrons are removed, now this 2, 8 and this is now your 1, removing 2 electrons. Two valence electron. Then this will be just like that of this hydrogen atom. So now this have only 1 electron in the outermost orbit, so now its spectrum will be same as the spectrum of the hydrogen atom. Hydrogen-like atoms now this is now your lithium 3, 7. So here this Z equal to 3. So this is not 2 and 1. Last electron is 1. Similarly, this is now your sodium 11, 23. Then this Z is equal to 11. So this is now your 2, 8 and 1. Calcium. Now this potassium K. This is now your 1938. So now this Z is equal to 19. So this is now 2, 8 and 8 and 1. So now last electron is 1. So this is just like the hydrogen atom. So now electron, the atoms having the 1 electron as the valence electron, they are called the hydrogen-like atoms. So now we will find the excitation energy. Excitation energy. Energy of nth level. This is equal to En equal to minus 13.6 Z square upon N square electron volt. So much. Now suppose we have to find for this lithium. Example we take for lithium. Example. Now we take lithium 3, 7. So now here this Z equal to 3. Then what we have? There is En equal to, therefore this En equal to minus 13.6 into this now your 3 square upon N square. So much electron volt. So now we will have this minus 13.6 into 9 and upon N square electron volt. So this En equal to minus 9 6 is 54. So this is now your 4, this is now 5, 9 3 is 27 and 5 32, 3, 9 3 is 12, 9 and this is now your 12. So this is now so much upon N square electron volt. This is now about the energy state. Now we take this N equal to 1, 2, 3. Now since the electron, if we find to this one, then this is now 2 and 1. So this electron is in second energy state. So this electron will be excited. So for the valence electron is in n equal to 2. This is now n equal to 2. So now for this n equal to 2, we will put to this one. This is now E2 equal to minus 13.6 upon 4. No, this is not so much. Minus 0.4 upon 4 electron volt. So this will be how much? Minus 3 to 4. Now then this is now your 0.4 to 3. 30.56. So much electron volt. Now from here the electron will be excited. So what we have? That this is n equal to 1. Here we will have the 2 electrons. Now this is n equal to 2. Here this is now only 1 electron. Now this electron will excite. So now this will be like this one. This suppose n equal to 3. This is now n equal to 4. Then this electron will be excited to this one and this excited to this one. So now we have to find the energy for this 3 and 4. So this is now first excitation energy. This is now second excitation energy. So now we will find according to this one. So the first excitation energy. First excitation energy of lithium 37 atom. Now this will be how much? EX1. Now this is your E2 minus E3. So E2 is how much? This is now your minus 30.6 minus. Now E3 will be how much? 122.4 upon. This is now your 9. So much. Now this will be so much electron volt. So much electron volt. With a negative sign. Sorry, E3 minus E2. E3 minus E2. So this E3 that is equal to your minus 102.4 upon 9 minus 1 to. Now that we are getting to this one. This is now your minus 30.6. So much electron volt. So this is equal to 30.6 minus 9 1 are 9, 3, 9 3 are 27, and this is now 27, so 5, so 9 6 are so much. Now this is so much electron volt. So this EX1 is equal to how much? EX1. This is equal to. Now this we subtract, so this is now your 0 point and this is now your 17. 17, this is now so much electron volt. This is for lithium atom. And now second excitation energy of lithium atom. Second excitation energy of lithium 37. So now this EX2, this is equal to Now this is your 30.6 minus 122.4 upon. Now then for second this will be now 4. So upon 4, so this is now 16. So much electron volt. So what we will have? In this place we will write down this 4. So 4 square to is 16. So this is now so much. So this is now 30.6 minus what we have? 16. So this is now 7 and then 10. So 104. So 104, that will be 6 and 8. This is now your 5. So much electron volt. So this will be your 5 and this 15. So this will be your 9 point, and this is now 1. So this is now 2 and this is now your 2. So much electron volt. This is EX3, EX2, EX2. So similarly, you can find the third energy, third excitation energy, fourth excitation energy, and so on. So this I have found for the lithium atom. If suppose you are given the ion, for example, the potassium ion, then we can have this, just you put the value of Z and then excite this electron will be excited to next higher energy state from the balanced energy state. Suppose balanced energy state is the 3, then 3 to 4, 3 to 5, 3 to 6. Now that will be the excitation energy, first, second and third. So like that you can calculate the excitation energy of the hydrogen-like ion and the hydrogen-like atoms. So this is about the excitation energy of the this hydrogen-like ions or atoms. So now here we have one conclusion, that excitation energy of hydrogen-like ions oblique atom is calculated from balance energy state to some excited energy state. Some excited energy state. So this is how to find the excitation energy of such kind of atoms and such kind of ions. So thank you very much.